projectiles in 1 dimension and 2 dimensions. A projectile is any object with motion through the air. For example, here the ball is kicked vertically upwards. This is one-dimensional motion. The motion is only in the y direction. Here we have two-dimensional motion. We have both horizontal and vertical components. We ignore air resistance, and the only force acting is gravity, and it acts vertically downwards. Here the ball is released and falls vertically downwards. I've taken this as the positive direction because it represents the initial motion of the ball straight down. Gravity acts downwards, so gravity acts in the same direction as this arrow here, so it's positive. The acceleration in any calculations would be positive. In this example, the ball is kicked vertically upwards. The initial motion is upwards, so I'm taking the upwards direction as positive, but gravity acts downwards, so the acceleration this time will be negative, because gravity is in the opposite direction to this. Here a ball is kicked upwards at 20 meters per second, the initial velocity. The upwards direction is taken as positive. The ball will slow down vertically until it comes to a stop. This will be the maximum height of the ball. We can calculate its displacement. This is the initial velocity. The final velocity at this point is 0, and because this is the positive direction, acceleration there is minus g, and we can calculate the time taken for the ball to reach its maximum height, subat. So we can use any of these formulae to calculate any aspect of the motion of this ball. In 2 dimensions, this is the initial velocity pointing in this direction. This is a vector. We have magnitude and direction given by the arrow and the angle. So initially the velocity is at an angle theta above the horizontal. The ball follows this path and it lands on a surface which is at the same level as where it started. Or the ball could land on a surface which is higher than where it started, or lower than where it started. Here the ball has an initial velocity which only has a horizontal component. The ball is projected horizontally from this cliff. There is no initial vertical component to the velocity of the ball. And here the ball is projected at an angle theta below the horizontal. So for 2-dimensional motion, we start off with a velocity vector, so we have magnitude and direction given by the arrow and this angle. We calculate the horizontal and vertical components for velocity. So ux in the x direction, uy in the y direction. We have these two perpendicular velocity components. Using basic trigonometry, the horizontal component is the adjacent to the angle, so u cos theta. The vertical component is opposite the angle, so u sine theta. So these components are the initial velocity components in the horizontal and vertical directions. We could use vector notation for problem solving, and our velocity vector here could be represented like this, but we will do more of this later. Now Vx and Vy represent the velocity of the ball in the x direction and y direction at any point along this path. These are no longer the initial velocity components. They are for at any point or at any time in the motion of the ball. As the ball moves, the vertical velocity will change, but the horizontal velocity will remain constant. I will demonstrate this. Look out for the length of each arrow. The length represents the magnitude of the velocity in a given direction. So we start here, and you'll see the blue arrow will remain the same length. The red one is getting shorter because the velocity vertically is decreasing, and the vertical velocity decreases further and again until it reaches 0 at the maximum height of the ball, And now the vertical velocity component changes direction, the arrow is pointing downwards, and as the ball speeds up coming down, we can see this arrow is getting longer, but this one is still the same length until it hits the ground. And just to go through that once more, for problem solving we look at the horizontal motion and vertical motion separately, and together they are used to solve problems.